Polarized light is a property of certain types of waves. It is light in which individual light waves are parallel to each other. Light vibrating in different orientations moves towards a Polaroid. All light rays with an exactly vertical orientation passes through. Since most light rays have a partially vertical and partially horizontal orientation, part of the ray will pass through while the other part will be blocked. The rays that pass through are polarized. The only type of wave that can be polarized is a transverse wave. A transverse wave is a wave that vibrates at right angles to the direction of its beginning. Though Vikings did not consider it a scientific fact, it is said that polarized light was already useful to humans during their time. Viking legends state that during cloudy days, the king would grab a polarizing crystal, hold it up to the sky, and be able to tell where the sun was hiding because of where the light shined on the crystal.
Iceland's spar had a very big role in the modern discovery of polarization, and it is still a preferred material to split the polarization components of light.
They used it to separate an image into two displaced images when looked through in a certain direction.
Later on, at the University of Copenhagen,
Erasmus Bartholinus, who was a Danish mathematician,
not only saw a double image in the Iceland spar, but he also ended up writing his 60-page memoir about his results of polarized light in 1669.
This memoir was the first scientific description of a polarized light effect.
Also in 1808 CE, the Malus law was created.
Malus law states that the intensity of the light transmitted through a polarizer when the angle of the transmission changes.
Polarization is the process in which unpolarized light is turned into polarized light. One of the ways that this occurs is through reflection. Metallic surfaces reflect light with a variety of vibrational directions. Therefore, this reflected light is unpolarized. However, non-metallic surfaces, such as asphalt roadways, reflect light in a way that there is a large concentration of vibrations in a plane parallel to the reflecting surface. That is why car windshields have Polaroids in them, to lessen the glare of the reflected light in order not to disturb the driver. Generally speaking, the uses for polarized light are of great variety. Polarized lights can be observed in digital watches, laptop screens, and polarized sunglass lenses. We imagine that most people have heard of the latter while shopping for sunglasses. The factories position the sunglass lenses in a way that only vertically polarized light has the ability to go through. This helps limit the amount of light that passes, thus making it easier to see. Here you can observe the difference between a polarized sunglass and a non-polarized sunglass lens. Furthermore, when watching a 3D movie, the required glasses have Polaroids in them. In this example, the glasses that have vertical Polaroids are used for sunglass lenses. On another hand, the glasses where one lens has vertical Polaroids and another has horizontal Polaroids are used for 3D glasses. When watching a 3D movie, you have to see the same scene in different angles. So one lens is polarized vertically while the other is polarized horizontally. Polarized light can also be observed in photoelastic stress analysis. In this example, you can see that when you rotate the tape holder, a slight glare can be observed on the inside of it. Polaroids are plastic sheets that have the ability to polarize a light ray. Polaroid films are added to car windshields in order to lessen the incoming glare from the asphalt reflections. Here you can clearly observe the difference between a car with a Polaroid in the windshield in contrast to a car without one. Polaroids are also frequently found in photography because they prevent the reflections that bounce off of flat surfaces from interfering with the photograph.